Alright, let's check the name. You can keep good again. Nan Chen Li, here. Cher Lin. Yahweh Cheng, here. Daniel not here. Who else? Who else is on the list that's not here? Ami, Sayyid Mohammed. Ami is not here. George Perdomo. George is not here. And that's it. Actually, we have just a couple more people left. Okay, first thing. Let me show you something about the calculator. Let's assume that I have some function and I have to use bisection method. Okay?
Hey, sir.
So let's assume that's my function. Sin x plus cosine x plus 13 minus x squared. That's my function. Okay. So how do I do it? Quick on calculator. Instead of x, I change to a and s. Okay. So I type 1. Enter. Now my a and s will be 1, right? I press AC, I go back up, so I change instead of x, I do a and s, cosine a and s, plus a and s squared. So let's say my left limit is 1. Okay, I press exe, so that's 13.3. You can do this. Let me set the left limit. Let's say my left limit is L. So I do 1 to L. So I set my left limit to be 1. Okay. Let me set my right limit. Let's say my right limit is 20. 20 alpha and R. That's my R.
6.
So that's my L is equal to 1. My alpha equal to R. Right? Okay. So if I type R, I press exe. Now my A and S become 20, right? My A and S become 20. So I press AC, up, 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 up. I press EXE, that button, okay? Numerical, can you check it's recording?
Yes, sir. No, it's not recording.
It's not recording?
It's recording. Okay.
It's recording?
It's recording.
So now I get minus 3.85 something, right? And I can record that value. Can I? I just press arrow and I press, maybe this is R, right? So maybe record it to S. Okay. Now I check my left limit. My left limit is L, so I recall L. Press the button, I get 1. And right now my A and S is 1. Believe it. Oh, wrong button. So my A and S is 1. So I press AC again and then I up. press ANS, then I can evaluate my value at 1, right? You see, that's a quick way of using your calculator. But first time when you type equation, you have to type, instead of x, you have to type ANS. And you store the value into L, store the value into R, and then keep doing it. Keep updating. It will be slow, maybe I don't ask you to do many times. For Newton method, depending whether you can do the differentiation or not, but I think you should, even though differentiation of sine x with respect to x equal to cosine x, right? So this kind of thing you have to be able to do. Okay? Dip cosine equal to what? Minus sine? Okay. So you should be able to do it. Use the calculator, do quick and do the exam Wednesday. On the exam, if you come late, I still allow you to do the exam, okay? It's your choice, but I don't suggest you to come late. Okay. Today we try to finish the Sympy, symbolic calculation with Newton-Raphson, and then finish and then move on to system of linear equation. Symbolic calculation allow you to get analytical solution by do the differentiation, integration, and solving nonlinear equation. Okay, that's a symbolic calculation. It allows you to solve a polynomial equation. For now, do you still remember how to do 2D list? For example, this is list containing list. Each row is the number from 1 to 10, 11 to 20, 21 to 30, and so on until 91 to 100. Can you do this? Daniel? Yes, no problem, right? If you have problem, you will have problem on Wednesday, okay? Okay, I think none of you come late. Let me check the name again. George, furthermore? Yeah. Okay. Ami, Sayed, Mohammed, Yun Hasib or Ami? Ami. Okay. Daniel here, okay. Landry, no. Hasib, no. Hasib, no. Yahoo. Temitope, yes, but okay. Alright. Let's do what we left last time. We finished root finding to some degree. Okay, you know how to do the rate of convergence. Okay, that equation to estimate the convergence rate. You know how to do speed test for the runtime. By now, you should know how to use SciPy.optimize. Okay, you know how to use SciPy.optimize, fixed point, bisection, and just f-solve, right? Fixed point iteration, you understand that it doesn't always converge. You can use f-solve. You know how to pass additional argument. You know how to do it for multiple answer. And you should know, by now you know, okay, list comprehension, everything. You know how to plot the graph. Bisection method. Do you know how to write this? Yes, George? No, not yet. I hope you know it by Wednesday. Okay. So by now you should be able to write the code for bisection method, at least with VBA. But you should be able to write it with Python, because I showed you the code. The code is just like that. Okay. Ami, can you do it?
Yeah, to practice more.
Oh, okay. You should be able to do it. Convergence rate. My bisection method. This time, I write it like manually, and I show you how to use SciPy.optimize, right? Bisect. Okay. I show you the idea on how to do bisection method. So bisection method, if it's not in the exam, you should be able to do it anyway. If it's in the exam, we will see if you can do it or not. Keyword argument, multiple input, So I told you how to unpack dictionary, use star, and how to unpack the list or tuple, just use one star. Right? We talked about that already. You know, everything that you learn in class, it doesn't mean that you know right away. You have to try. You have to write my code, and you have to run it. If you have not done that, I strongly encourage you to do so. Newton Raphson, we talk about algorithm, find the slope, follow the slope, right? Creating class, you should try this. It doesn't work by just come to the class and listen to it. You should try by yourself. Did you try? Temetope, of course, you didn't try this last time you didn't attend. Yahweh, did you try? Why not? Because you don't care. Oh, okay. You didn't enroll, so I don't pick up on you too much. So class, we have def init. We tried last time. Fixed point, bisect, add. So operator overloading. Now you can overload the operator with add statement. You can have minus or multiply or something else. How do you do that? You open NumPy documentation and follow it. But I just showed you some cases, okay? We finished with that. Right now, let's do symbolic calculation. Hey, let's solve x squared minus 7 equal to something. Oh, by the way, for today, we will cover the symbolic calculation. We try to finish it. And then we move on to system of linear equation. Okay? Symbolic calculation, yes.
So, agree. So this part is not in the example. We're not covering the example.
No. Whatever we cover today, starting from here, won't be in the exam. You see the example, right?
Yeah, right. So, and also we can't use the NumPy style app package in the example.
I don't know, the exam is not supposed to be known before the exam time. I just give you some example. If I know, I don't tell you either. Okay, you just know what I give you, just that. And there's no O exam. That's what you have. The real exam. I can do it. Let's put it this way. For the real exam, I can do it. I have done some of it. Long time ago, I have done some of it recently, so I can do it for sure. I know that it can be done. Okay? Let's move on. The exam. If you want to talk more about it, come to see me after class. When you come to see me, you tell me what's your objective of meeting. We will move to the point because we may have not just you, right? We may have Yahweh come, Ami come, Tomato Pay, he don't come. We may have Daniel and we may have George and many people may come. So, or you may come at the same time, no problem. Okay, let's take a look on how to do solving polynomial. I do np dot roots 1, 0, minus 7. So 1 is that number. 1 multiplied by x squared. Okay. 0 is 0 multiplied by x, which is 0, and you don't see it. And minus 7, so 1, 0, minus 7, those are coefficients. Got it? So when we solve it, numpy.root, it tells me that's the root. Like plus square root 7 and minus square root 7. Answer 0 square, answer 0 is this term, right? Square equal to 7. Answer 1 square, that term equal to 7. So now we can solve, get numerical value of polynomial quickly. Use numpy.roots. You still have question on this?
Yes, no, it's easy. What I'm trying to say is that, okay, what if it's a cubic equation, you know?
I don't answer your question not because I don't want to answer, because I want to cover this material thoroughly and still want to see if you can answer that answer yourself or not. But my short answer right now is, please bear with me and be very patient with me. We will go through all this, and if you want to know more, step 1. If it's not urgent, try. What if it's cubic equation? What do? You cannot actually use this equation right away, can you? You have to read the documentation. You have to
you need to know what to press. What is the button to press? Daniel, what is a button to press? Two button to press.
Shift out.
Yeah. Ta-da, that's the answer. So if it's a cubic equation, I guessed that you add one more number over there.
4.
But I don't know for sure. I may try. I may open NumPy documentation, okay? Let's finish this so we don't fall behind. Let's take a look at this. I can define the function lambda colon x squared minus 7. Do you know how to do this? Lambda function? You don't know, it's serious, you know it, right? Okay. So we do scipy.optimize.fsolve and we pass the function and we pass the, what's this? Minus 5, 0, 5. I think that's the initial guess. So with 3 initial guess, we get 3 answers that way. So that is numerical calculation. But if you want to, what do we do if we want a unique answer? We don't want that and we don't want that. Those are same. We should combine it somehow, right? I don't like that we have same answer twice. Do you like it? If you use NumPy or NumPy.roots, you get unique answer. Right? But if you use fsolve by starting with different initial condition, different initial guess, you get 3 different answers, but 2 of them are the same. This one and this one can be the same answer. Sometimes they are almost the same, but they are not identical. For example, the 10th or 15th, the 15th or 16th digit may be a little bit different. So the very, very last digit, it may be just different because the computer has a certain accuracy. What do we do? How do we combine things together? We use set. Set give me unique answer. Okay, but before I can use set, I have to look at this one. Single quotation mark, that dot format, I. So dot 10f means 10 digit. I just shorten it into 10 digit. And this thing will be string. It's not float, it's not number, it's a character, it's string. So first I create a string that has just 10 digit by use dot format, right? And then I use float function to convert from that string to be float, to be double. And then I use the list comprehension for every I in answer ANS. Then, and I put this curly braces in the front and in the back. So it's not list comprehension, it's like set comprehension, create a set. So this way, if we just extract first 10 digits this way, okay, of course there are other ways to extract, but this is one of the ways to extract. I put it in string format first, okay, and I just take 10 digits. So this way, if they are almost the same, for example, the digit number 11, they're just a little bit different, but I don't care. When I extract just 10 digits, they are just the same. And when I just use set for something that is the same, they just take one, they don't take twice. Okay, so that's how I get this number. Just 2 numbers. For polynomial degree 2, we have 2 answers, right? We don't have 3 answers. All right, let's move on. So that is the, yes.
What does the 10 have to do with the number of values we got? We got 3 values, but just
But I don't
10
like it.
digits.
But I don't like it.
But,
For the, what I mean is, for polynomial degree 2, we should have 2 answers.
Yeah.
Mathematically, we should have 2 answers. But fsolve give me 3 answers because I have 3 initial guess. Okay, how do I collapse from that 3 answer into 2 answer automatically? How do you do that? We now use human to, hey, let's check. Oh, we have 2 answers are the same. So how do you collapse the number that they are the same or almost the same together? You may use your method, but my method is this. Nice This is to show you how to collapse the repeated answer together. They are not exactly repeated answer. Sometimes, okay, look at this one. When you have different initial guess, the answer will be a little bit different. A little bit maybe 10, 1 times 10 to the power of minus 17. Very small difference. But even very small difference, if you directly put into set, it considered as two separate numbers. Okay, that's why I extract as 10 number. Is this kind of clear to you? Why do we doing this?
Yeah.
Okay, let's do analytical solution. To do analytical solution, we import Sympy. Is there a way to make it colder in this one? I think it's a little bit hot today.
No, I just curious about the.
No, I'm asking about AC.
Oh, no, it's not.
It's like this every room.
Yeah.
Maybe okay. Let's finish quick. Alright, we use Sympy. I import Sympy as SM. Okay, Sympy as SM. So SM is Sympy symbolic computation. Now the answer is okay. Instead of number, I get minus square root 7 and plus square root 7. Nice. Okay, it's simple. Okay, what I do is I declare both x and y to be symbol x and y. Okay, so this line 93, is to declare that x and y, they are symbol in symbolic computation. Okay, that's the first step. Otherwise, if you don't declare it first, it's kind of crash, like type mismatch. So I type SM, which is Sympy.solve, parenthesis x squared minus 7. So this x squared minus 7, that this x is the symbol. Okay. I get minus square root x and square root x. Oh, I'm sorry, square root 7 and plus square root 7. If I want a cubed form, I do init underscore printing, use Unicode equal to true. And I type f solve again, or just solve sm.solve. I get square root sign. Okay, minus square root plus and square root 7. This is analytical solution. So let me define a group of symbol, or you may say, okay, this is an expression or equation. E1, equation number 1, equal to x squared minus 7. Sm.solve E1, give me that. E2, instead of minus 7, I use minus y. It gives me minus square root y and plus square root y. So it's symbolic computation, okay? And you can adjust it as complicated as you need to. What about differentiation? Let me do partial differentiation. At E2, okay, I differentiate it with respect to x. Use partial differentiation. So partial differentiation of y with respect to x is 0, but x squared, I get 2x, so that's I get 2x. Can do differentiation. So answer is differentiation answer. Type of the answer is something, 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 something. So it's not float. Okay, it's not character, it's not string. It's that type, sympy.call.mul.mul. Alright, what if I want to change the symbolic result from Sympy to be lambda function, like Python function, regular function? I use sm.lambdify. So lambdify require me to tell, hey, what is the parameter? I tell, okay, the parameter is x. And what is the answer? I mean, what is the equation? Equation is 2x, right? That is the equation that I put here. So lambdify means change from Sympy symbolic function to be regular numerical function. So pi function 2, it multiplied by 2, it gives me 4. Okay? So that's how we switch between symbolic function and Python function. Type of pi function is just function. Okay, now if I have more friction factor, Reynolds number, epsilon or pipe roughness and diameter, I put okay sm dot symbols. In parentheses I have string and I separate them by one space. So this means I declare those parameters to be symbol or variable in Sympy. And I type okay, finding friction factor E2 equal to 1 over f star star 0.5 plus 4 star sm function dot log blah 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 blah. Look at this. When I use function, logarithmic function, I cannot just use any log function. Why is that, Yahweh? Can I use math.log or numpy.log? Yes or no?
No.
Why?
You can maybe, but you have to import the numpy function or math
It
function.
doesn't work. I think I can because it doesn't work. I tried with this numpy function, it doesn't work, and it's like type mismatch. Why do we have type mismatch?
So,
Because we are doing symbolic computation. For symbolic computation, we need symbolic logarithm. NumPy logarithm give us number, right? But symbolic logarithm give us symbol from the computation. It's not just any computation, it's a computation that do symbolic computation. It's not, the answer is not number, but it's a symbol. So if I use log function, I have to use log function of Sympy. What do I do if I do log base 10? It said comma 10. That's log base 10. Okay. Now I lambdify the Sympy function to be regular Python function. The first part, I pass the tuple of parameter. So this function will be, we have f, we have re, d, and ep. And I put default value. Okay. By default is equal to 0, equal to 0, equal to 0, 0, 0. So this is list of parameter. And then I pass the function, Sympy function. How do I know that I have to pass it like this? I press Shift Tab, okay, to see the documentation, or you go to Sympy website to see the whole documentation. Okay, Python 0, re equal to that, f equal to that, d equal to that, ep equal to that. I get this. Okay. So what's that mean? We finish the conversion. We convert from Sympy symbolic computation to be regular numerical calculation in Python. So if I have function def x re something something something, and this time I use math.log. So this is finding friction factor equation or function defined usually in a typical way. I check the number from both methods. They are kind of the same. Okay? They are the same. So this is to show you that the conversion is correct. The conversion is equivalent to type it directly like that. Why don't we just read the answer and type the function manually? Because we want to automate it. Let's say you want to do Newton method, but you don't want to differentiate by yourself. You want computer to do differentiation for you. Typically, computer cannot do differentiation for you. Analytical solution, it cannot. Okay? So you use maybe Mathematica. You can use this one. MATLAB can do symbolic computation too. But you see the price already early on, right? How much they cost. It costs more if you want more from it. Sympy is free. Okay? Good? Alright. Next step, lambdify parameter, lesser parameter in string. Okay, this is string, you see, and actual Sympy equation. I put it there, I get Python function. Okay, 0b, when I pass the value, I just show you two kind of passing the value. First one I do 0.001 on E5, but this time I do RE equal, F equal, so pi func 0b and pi func 0. One is without equal sign. Another one is with equal sign. Both of them work correctly, but if you don't have equal sign, your argument has to come in the right order. Okay? Your argument has to come in the right order. If you have equal sign, you may switch the order a little bit. Okay. Have you ever do the differentiation of the... I think he's sleeping. I don't think he's just like lowering his eye. I mean, yeah. You just concentrate, is that what you're doing?
Yeah, that's.
When he concentrates, you do this. Don't concentrate too much, okay? So, if you do the differentiation, you do Sm.diff. That's, you get it. Wow! Is that correct? When you do .diff, the first one is your function, right? The second one is do the partial differentiation with respect to what? Now you do the differentiation with respect to f. That's what you get, right? Okay. In Newton method, you need a slope. When you need a slope, you do the differentiation according to with respect to f. If you want to find f, right? Okay. If you want to find RE, you find the slope with respect to RE. Let's lambdify it. So we lambdify Sm.lambdify. So we change the symbolic differentiation result to be numpy function, and we can calculate it like that. Okay. Look at this one. I do the comparison. This is analytical solution from numpy, and this is finite difference. Use central finite difference. They are not the same. They are almost the same. Minus 1.4 e minus 8. They are almost the same. So when you do Newton-Raphson method, and if you ever use the method of finite difference, okay, to get the slope, this means that your answer cannot be more accurate than the error from the slope calculation. Okay? Alright?
Can you explain this? How did you get this underscore dash underscore?
Oh, what is 1 underscore? 1 underscore is previous answer. 2 underscore is previous answer of the previous answer. 3, and we have 1 underscore and 2 underscore. So this line mean underscore mean this number, and 2 underscore is that number. So basically it's a comparison between the answer from symbolic computation and the answer from direct finite difference. If you do finite difference, one of the reasons that you do finite difference is because you don't want to do differentiation. The equation is too long, right? And if you do it by hand, it may be wrong. But if you want it to be correct, you can do this. Okay? Of course, be careful when you do this. When you get the answer from computer, it doesn't mean that it's correct either. You have to check. Do it right. Next, let's talk about substitution and evaluation. You have the equation E3, which is the differentiation result. Now, if I want a number, what do? I can do E3.subs and give the dictionary mapping between variable name and variable value. Okay, variable name colon variable value, key and value pair. Okay, I give the dictionary between variable name and variable value and use .sub. This way it substitutes the value for you. And when I evaluate it, it still don't tell me the actual thing, okay? It just doesn't tell me one number, it tell me this, minus something over something. If you want just one number, you can do dot eval f, or maybe dot n, get the numerical value. Okay, so if you have simple expression and you want to simplify further and get the numerical value, you can do dot eval f or dot n. Try them over yourself, okay?
What's the difference between the two?
I don't know. You read documentation. Okay. Both work fine. I don't think they are the same. At least the number of characters at that time, on top of my head right now, I don't know. But I want to know both because sometimes one of them doesn't work. Okay, that's how I know both. When I learn about this, sometimes I use this, it doesn't work. I Google it, go to Stack Overflow, they say, hey, let's use .n, and okay, it works. Integration with Sympy. You did differentiation already. Let's do integration. X, y equal to symbol x, y. Sm, integrate x comma x. Integrate x dx with no boundary. You get x squared over 2. Right? Integration of x, get x squared over 2. But if you give it the range, maybe from 1 to 20, you get something else. Integration of log x dx. What do you get? You get x log x minus x. Do you believe me? Yeah, then you should because I checked already. If you differentiate this, you get log x. When you put, okay, one thing to be careful is this. Whenever you do simple calculation, anything that you put, special function like log, sine, use Sympy log, Sympy sine, okay, not just regular log or regular sine. Integrate, Sm dot integrate log x dx, substitute at x equal to 2. So you do this calculation and then substitute x to be 2. If I want a number, I have dot eval f, open and close parentheses. Okay. Dot n, okay. Dot eval f, open and close parentheses, I get a number. Alright? Integrate log x of x from 0 to 10. You remember the log curve, right? It go like this. Inverse is the inverse of exponential. So, what is the value of log 0? Volunteer. John?
Log 0?
Yeah. I don't agree. Log logarithmic of 0. What do you think? 1? Do you agree with him? You should say no because I say no.
Size not 0.
Log 0 is minus infinity. Okay? So log curve start from minus infinity. Can you restart it?